The universe travels the path of entropy. The only way forward is chaos. What is up, YouTube? Welcome back to episode 6 of the Draco build. Before we get into it, I just want to say Happy New Year. Welcome to 2021. I hope this is going to be a fantastic year for everyone, unlike that garbage dumpster fire that was 2020. For me right now, it is still 2020. This is the past. You are in the future for me, but technically I'm in the past. You're in the present. Timey-wimey stuff. It's annoying. Anyways, big shout out, big thank you, first of all, to Mike Patey, who saw my comment in his previous video. Thank you so much, Mike, for the kind words, and thank you to everyone else that's come across from Mike's channel and subscribed or just see what I do. And my view count just went like this on Christmas Day. It was amazing. Best present ever. So thank you very much, Mike. Thank you to everyone else who's joined, and I hope you like what you see. So, yeah, a couple days ago, I started working on the Draco project again. I just couldn't sit still. I was enjoying my break, but then I was just like, you know what? I just enjoyed working so much more, so I'm going to go back to work. And boy, did I get back to work. So I've done it again. I've done too much work because I set myself a deadline, or rather a time frame, to when I would be putting the next video out, and that was New Year's. As it is, I screwed up with my estimations of how long this would take and how much I would get done. So I have more footage than I cared to put in a single video. So I'm going to break it down into the 3 big components that I worked on. That is the framework for the power pack assembly, gear reduction box for the motor, because turns out I didn't know what this motor did and how it worked, and now I do, and I have to change my plans. And third, the variable pitch prop assembly, or the collective, or whatever you want to call it. It is the complicated mechanism that attaches to the hub and makes the propellers change their pitch when they're going round and round at the same time. I'm going to jump into Inventor and show you guys what I've done, go over the main components, throw in a bit of the time-lapse footage here and there to show you how I did stuff. But generally, we're going to try and keep it all concise, because just sitting there waffling on about how I made something gets old after 25 minutes. Yeah, that's how much time-lapse footage I had. Yeah, let's go. So here we are. Now, this project is getting a bit much for my computer to handle. So, like, opening these files now takes about 4 or 5 minutes just to open this assembly with everything in it. So we won't stay in this assembly too long, but I just wanted to give you a quick overview of how it looks. She's getting there. She's really getting there. We now have the propeller attached to the airframe. It is all, well, no, that's not true. It's almost attached. We have the bit that it is going to attach to done, but it's not attached to the thing that attaches to the airframe yet. But it in theory, it's attached. Just pretend they are attached, okay? It's all one contiguous part. Well, not multiple parts, but yeah, you get it. I am blown away with how this turned out. I did not expect it to look this good. I can't wait to now go back and get the nose cowling up and running again. Oh, wow. Oh, that does look good. I mean, it's a little bit off. It's not right, but that is awesome. This is going to be so cool. Anyways, let's get rid of that again, because it's borked, it's broken. And let's open up what we've come here to see. Okay, we have the variable pitch prop, we have the motor gear reduction, and we have the framework assembly for the firewall mount. This holds this front end to the plane. It's pretty simple, but it's very important. It's a very important piece. So that's what we worked on. I decided that instead of just building a boring, get the job done frame that holds the motor and the prop assembly and the batteries and everything, the batteries are hidden in here, why not go a step further and actually make what you see on the actual plane? So this is a photo of when Mike had just put the PT6 Pratt & Whitney engine on here, and he just finished making his custom tubular engine mounts. So I figured, when I looked at like the size of the batteries, the ESCs, and the motor, it all looked pretty contained. Like they weren't very large compared to the aircraft. So I thought, what the hell? Why not I just make a fake looking PT6 engine that is a hollow case that actually has all the structural mounting points and hardware for the motor, for the gearbox, for the VPP assembly, for the servo, for the VPP. Put it all inside of this fake turbine engine motor, and it would hold everything, and it would also look really cool. So when you take the cowling off the engine, the cowling off the front of the plane, you see this, and then you would just separate it from this point here to access the batteries and everything. And you think, well, that's a lot of hassle just to get your batteries in and out of a plane. Why would you make it so difficult? Well, I'm kind of doing it on purpose because I want to visually inspect the gears on the gear reduction box every time before I fly the plane, after I fly the plane. So that's every time you put the batteries in and you take the batteries out. This is a key maintenance issue because if they fail, then the plane fails. Same with the variable pitch propeller. And here we have the variable pitch propeller. So this shaft here spins with everything. This all spins except for this outside bit. This outside bit will be on a set of rails and attached to a servo, and the servo will drive this back and forth, and that drives the propellers. Nice and simple. And then there's a bearing on the inside here that allows the inside of it to spin, where there's a pass-through rod that goes to the inside of this drive shaft, where you can see down the middle, which then goes to the inside of the propeller. If we just hide this piece, you can see the collective plate and that rod that goes through the middle there, which comes out to these cams, which will be permanently affixed to the propellers, where they've got this hex attachment. This aligns them in the right angle, and then I'll be using the same epoxy to actually make it all one piece. And then on the inside, I have two thrust bearings that will be captured between the propeller and the cam, and then held by the cone assembly, the spinner. So when that goes together, they don't come apart, and that's by design as well. If something breaks or I damage a propeller, then I'm going to have to snap that cam assembly on the inside to remove the propeller, print a new one, and reassemble it permanently with a new cam. So I will replace all of those parts except for the bearings if the bearings aren't damaged. That's also by design. Yeah, you'd think, okay, what if you want to just pull it apart for maintenance and stuff? But I'm like, no, this is a delicate piece, it's going to be under huge amounts of forces and loads, and any kind of added complexity or parts or anything that comes apart, it's just more places for stuff to go wrong. So I've made the sacrifice to make these props and cams all one piece in order to, take advantage of that extra strength that I get from making it a single piece and not have it come apart or have more parts or just more weight that's spinning around here at, 6,000 to 8,000 RPM. It makes total sense, but yeah. So there you go. There's a nice cutaway. You can see it all. You can see the bearing there. This slides back and forth, turns the propellers. I love it. It turned out really nice. I'm really pleased with the way it turned out. I just now have to make the framework for this slide. It's gorgeous, nice clean lines. Everything's designed to have the structural component as well as an aesthetic component. I just love trying to combine both those aspects of something. And then also as simple as possible, as few parts as possible, as little things that can go wrong possible. And that was the goal when I set out to start making this. And I think I fell right in that maximum number of parts needed to pull this off. And it came out really nice. So that all gets covered up with the drive shaft plate, which is currently hidden. That tube gets fixed to this plate, and there's a double socket inside here where it all gets stuck to with some epoxy. Same with the inner rod will be permanently affixed to the cam, as well as to the pass-through cap. Where this pass-through rod goes through, there is a cap on the end. You can see it just in here. Let's switch back to technical illustration. You can see it just here. So this cap is affixed to this rod. It can all still come apart by removing the pass-through rod, and you can pull it apart to maintain certain things, but other things won't be coming apart again. The big thing is that there are some bolts in here to attach the collective plate to the cams, but this is because I want to be able to adjust the tension by how far in or out that bolt is in the cam to adjust the tension for the slot, how freely it will move. I will see how it goes. I can always change this later down by changing the design and printing new parts. It's not a big deal. But yeah, this variable pitch prop assembly turned out lovely. Man, it's a mouthful. Try saying variable pitch prop 50 times on a stream or on a video when you're recording. It's not easy. So that turned out great. Then we have the gear assembly. Oh, now this is another kettle of fish. Let us just hide the ring gear quickly. We have the motor mount, which is this plate with these 4 posts. That mounts to the motor through these 4 socket heads. Then you have the gear tooth for the motor, the drive, comes into the middle. And then on these 4 posts, there is a double bearing set with these 4 planetary gears, which are then additionally held in place by this cross beam sort of alignment plate, which also holds another bearing which holds the ring gear, right? I mean, I don't think you could make this any more compact. That is about as compact as I could make it. I could probably make these shorter, but I'm limited by the actual the gear on the end of the motor, and I don't want to print this drive gear because this is going to be doing like 30,000, 40,000 RPM. I will keep that as metal. These come down to about 20,000 RPM. That's why they're on a double bearing and really well secured and very broad and thick so they can distribute the torque and the RPMs. And then this outside case will be anywhere from 0 all the way up to a maximum of 8,000 RPM in design. So I might have to come in and thicken the wall thickness of this, make it a bit beefier, but we shall see. I can always print a new part. It's all a bit trial and error. I am going to run this through a stress analysis simulation to see how it behaves, but it is a little bit tricky because it is a cylindrical part. With the propellers, they're a single part, and I can run a gravitational transform on it to do a simulation on how many G's it would endure. I can't quite do the same thing on this. I'll see. I'll go do some Googling and see what I can come up with. And the final thing to show you guys, we just had a look at all this. Now let's have a look at what I did here. And this is what I did first. So really I've looked at this in the backwards order. I did the VPP last, but we looked at it first. Anyways, let's open this up. This is the fake engine casing thing, right? Now, this is going to have a lot of forces translated through it, through the outside of this ring, to these 3 tabs. And those 3 tabs are then attaching to these carbon fiber rods that are distributed to the firewall of the aircraft. There's a lot going on here. So let's see if I can zoom in on a section. This is pretty overbuilt, right? I have a cross-sectional I-beam that follows around the inside of this thing all the way around. And I've cut some holes in that I-beam to lighten it up. And then also I have this distributed arching that comes off the bottom face of the I-beam to this outside neck here. This is going to have some sort of locking mechanism on it for the front end of the casing. So this is the aft section of the casing. I still have to work on, wait, let me just, right. So this is the aft section of the casing. Am I the right, wait, no. This is the aft section of the casing, and I still have to work on the front section of the casing. So that's going to have some sort of locking mechanism on it around here that'll allow me to attach the 2 pieces together. But on the inside, I have, I'll just have to switch back to shaded because of the performance issues. I have this tray that is attached through these 3 little eye-hole beam things, which slide onto these rods which are secured on the inside to this case. So my battery tray slides in place, and I'm going to have some caps with some screws or something to lock it in place. And I've still got plenty of room to adjust the spacing of these batteries, so I can design different trays for different batteries and different alignments. I'm still thinking of maybe creating an attach point, a mounting point on the underside of it here for the ESC. The power leads, there's plenty of space at the bottom here for the power cables for the batteries. And they would come into the back of the ESC and attach there, and then you got your 3 outputs here, which would attach to the 3 inputs on the motor. And I'll push the motor out of the way over there. RIP headphone users, fair warning, turn it down, 3, 2, 1. Right, there you go. So that's pretty much the spacing we're looking at. I think I actually need to shorten this drive shaft a bit and knock another 50 mils off based on what we saw before when I showed you the casing. But there it is, that's all I've got done for this week. Next week I'm going to be finishing off this casing, the front end of the casing, all of the mounting points, all of the air channels, airflow for the vents on the outside of the cowling that come to this. So it's all going to be functional. The airflow from the underside of the cowling comes up into the motor, blows out the back of the motor, and gets channeled through another carbon fiber tube that will be part of the structural internal structure that holds everything, goes to the front, distributed to the sides, comes out the side of the external cowling where the exhaust pipes are on the actual plane. So we will have functional inlets and functional exhausts. I mean, it won't actually be exhaust coming out, but it'll be the hot air from the motor. I think that's really cool. I just love the fact that I can do that sort of stuff with this kind of 3D printing, with resin printing. You can't really do this with FDM. It's not worth it. It's too much hassle, and it doesn't turn out as well as you want. I'm doing it because I can. So it'll be awesome. And there we have it. Wow, that was quite a lot. Hope this video didn't turn out too long. Thanks again, Mike, for seeing my stuff and the compliment you gave me, and how I'm so glad that you really made your gear. Like, that was amazing. That meant a lot to me. If you do see this in the future, if you are following or subscribed, yeah, that's awesome. Leave a comment. Tell me what you think. Any kind of feedback would be great. I'd love to hear more about if I can use the logos like flying cowboys and stuff on the plane when I build it to give it more of that authentic look. I'll probably see if I can contact you somehow and get that organized. But yeah, thank you to Mike. Thank you to everyone else that's come from Mike's channel. So glad to see you all here. And I look forward to doing some more stuff in the future for you. Happy New Year, everyone. Happy New Year. That'll be it for episode 6. I've been Chaos, and as always, expect the unexpected. I'll see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.